Ana? Klaro na class?
Yes, sir.
Okay. So, how about the voice? Maklaro? Dili choppy?
Klaro ra, sir.
Okay. So, dirahan tani. So this will be only short. Anyway, I'll be uploading the video and I have already what is it? The lesson na katong lesson na gipang-upload ako katong format. So I'll just upload it later, no, for you. For that, na mo'y additional, na mo'y reference or na mo'y mabasa-basa aside sa video, no? Okay. So now let me discuss the lesson 1.3, the pre-engineering surveys. So outcomes for the lesson is to recognize the required pre-engineering surveys for a construction work and prepare engineering survey plan. Though we can attain this outcome once I already given the activity assessment and the laboratory exercise. Okay, so what we will just focus for now is recognizing the first outcome. No. Okay. Okay, so going back. So actually, in preparing pre-engineering survey plan, so we have the relocation plan, topographic map, and I think that's it. Okay, so again, engineering surveys is a survey that involves oops, sorry. Oops. Wait, Sakura-san. Okay. Sorry, cannot play. There's presenters here. Show presenters view. Okay, so going back. So we have here the engineering survey involves establishing of control points. So it could be by traverse, by baseline, or other methods to obtain information required for engineering designs and to set out construction points from design drawings by the use of these control points. Then it involves topographic surveys, and the maps produced by them provides horizontal location information and elevations needed for the design of structures such as buildings, transmission lines, and sewers, and so on. No, so too many to mention. No. Then from the design, these works are then laid out from the same control points used in the original engineering surveys. So the same with conducting cadastral survey or different kinds of survey. First and foremost is we need to establish controls, no? Because this will serve as our reference for laying out points based on the design, diba? So if we don't have control points, then we just arbitrarily select points, but that would be not economical because tendency will be having some encroachments because we did not establish the boundaries well and so on. Yeah. So that's why it's very important to conduct a survey or pre-engineering surveys before the construction proper. Anyways, and also the activities involved vary according to the type and complexity of the engineering or construction project. So not all the time dapat ka ni buhaton, but we will just state here what are the basic requirements or objectives of engineering surveys, diba? So again, pre-engineering surveys defines or depicts that we need to locate the position of natural features and positions of the built features. So if that's not clear for you, so let's proceed first with this slide. Okay. So first, I'll just repeat it quickly. So before anything, we need construction project to be done. No, first and foremost, ang survey muna in layman's term, no. So we need to set up control points for the reference in designing. Then once we have the design, we laid it down to ground. So how do we lay them out? So since we already established those controls, then we use the design or the design or plan. Then we can lay out this into a reality. So from paper, from plans to reality, no? So that's that's our purpose, no? As an engineer, yeah? So that engineer. We are responsible for this kind of work. And so the responsibility of the geodetic engineers or surveyors or engineers, no, during the construction is first, we need to establish or we need to conduct control survey. So we establish control points as reference, diba? Not only reference for initial survey, but it could be used as reference for the future survey as the project progresses or as if project moves on. Diba? Next is we have the relocation survey or verification survey. So relocation survey, is it necessary? Ikaw, Pumentil, necessary ba ang relocation survey? John?
Pardon, sir?
Necessary ba ang relocation survey sa, let's say, sa
Yes, sir.
project? Okay, yes. If yes, why?
Yes, sir.
Why?
Uh,
It's okay. Anyways, so, ano siya, no? So, the answer is yes, and why? We will talk about it later. No? So, okay, thank you, John, for answering. Then, next is the topographic survey. So, maybe some of you already knew what is a topographic survey, no? That is by means of gathering information of built features on the surface, no? Then next is taking out the facility on centerline or on offsets, measuring quantities reflecting the progress made by the contractor during that time, and as-built survey. So these are the common or the major responsibility of a genetic engineer or surveyor or engineer. So, no? Maintain the control points, to conduct relocation survey, um, to conduct topographic survey as if it's required, no, in designing, then staking out the facility on centerline or on offsets. So since if you are familiar with, di ba, if we build something, we need reference, we need to stake out points for that. The builder or the contractor will have a reference for him to build the structure. No, it could be road, it could be building, it could be any kinds of construction. Yeah. Then another responsibility of the engineer is to measure the quantities reflecting the progress made by the contractor during that time period. So what does it mean? Some of the contracts project construction project, no, the mode of payment is based on the progress the contractor made, di ba? So that's the other job of the engineer. It's somehow a monitoring. No? Yeah, right. The right word is monitoring. So the engineer monitors the progress made by the builder or contractor, then based on the progress the contractor made, so that will be the basis for the payment or initial payment, di ba? Then after that, or items one, the first, second, third, this is somehow the focus for today, and it's in order. Pwedeng mauna ang relocation, pwede po mauna ang consultor. I prefer the location should be first set before, then we conduct control survey. But anyways, so it doesn't matter which comes first as long as we conduct these three. Then the last is the as-built survey. So as-built survey is somehow a survey which is depicting the latest how do I say this? It's the same with this statement, no? What is the progress made by the contractor? So somehow in an no? So or the actual, di ba? Actual survey, no? Which is the as-built. So the genetic engineer survey the building if it's within the design criteria, no? As-built survey is somehow a monitoring survey in in a in a easier sense, di ba? Okay. Then, so here are the basic construction objectives of surveying. So the basic objectives of construction surveying are First is to provide layout stakes horizontally and vertically. No? This is very important because most of the contractors doesn't know where the construction should start, what is the elevation of this point, and so on. It's very important as the role of geodetic engineers to establish or to lay out the stakes as guides, because this stakes serves as guides in laying out or in constructing uh, constructing structures. So, second is second is we the we need there's a need to replace layout stakes, because why? Some of the construction equipment, or for example the road, di ba, we lay out stakes sa ground, then the simintoan siya. So tendency ito na mawala yung stakes o na maibot, so therefore we need to replace those stakes. For that, nagyapon kay guide, no? Then other objectives is periodic checking of projects, ensuring compliance of the design standards. So it's the job of the geodetic engineer to check this if the structure is aligned with the design, if wala ba changes sa iyang pagtukod, pagsimento, or pag-excavate, diba? So we do all that things, diba? And other is the geodetic engineer should provide a map, or as we call the as-built map, after a project showing the final projection, location, and configuration. If there are no changes, or now it's very important na though we have design, there are some tendencies that the design cannot be fulfilled fully. So there might be changes on the actual area. So that's why we perform as-built survey to check if the actual building or actual structure or actual construction project is aligned with the design. If not, we compare the as-built survey results and in the design. If they are the same, then there are no changes. If there are some changes or configuration, then that's the time we update the design or final design of the structure. Huh? So why do we need it? Because it is needed in the future. Like, what if they decide to redesign the structure, redesign the road? So at least they have the actual, or they have the up-to-date design. Okay. So again, sir, there is no strict procedure that governs the construction survey, as long as the basic objectives were met. So the GE provides sufficient information to the clients or builders or contractors based on the accuracy and methods employed in gathering measurements and being resourcefulness. So in general sense, that what I say, there are no, not meaning to say no rules, but as long as the objectives were met, no matter what methods you are using, what technologies you are using. So we are mentioning methods and technology, which is the geodetic engineer that are geodetic engineers using. You know? So I think that's not that problem. And if you'll be having your OJT, if you decide to have construction firm, so most of this my experience nimo, no? Okay. So now let's proceed to control surveying. No? So this is the most important, or not the most, the key factor of the success of construction project. Diba? So again, this is done before the design and construction of a particular project. And the control surveying or the controls, the established controls by this kind of surveying is used in topographic surveying or mapping. And again, we establish horizontal and vertical control, which will be mainly used as reference in construction projects. So horizontal control points were used for locating horizontal points of the structure. It could be road, it could be building, it could be bridge, or whatsoever. So typically, datum, selection of datum is very important for this one, especially if there's a discontinuity of the surface or land, no? Dapat the same of datum. So if they create a bridge, mag-abot rin na sila. The same with vertical datum. There should be a uniform reference system when dealing with this kind of projects. So for vertical, so that is we are dealing with elevation or height, diba? So if we are dealing with high-rise buildings construction, so it's very important to establish a vertical control, no? Or as well, the control, no? It's very important to have a control for a certain project, no? Because this will serve as guide for the design and guide for laying out based on what the design is telling to, diba? Then again, these monuments must be placed for a long term, no? Not only for initial surveys, but it should be present, or it should be how do I say this? It should be maintained until the completion of the project, and also for the future use, no? What if they decide to extend the building, extend the road, extend the bridge, no? So at least we have still an existing control na we can use. And it should be noted that it should be placed in a distance in which these markers or monuments will be unaffected with the progress of the project, no? So the difference with stakes, stakes are guides on the ground. The tendency they will be vanished or they will be removed because of there are some construction equipment that will be passing. For the control points, this is different. It should be placed not so far away and not so near with the construction site, so that in the sense that they will be unaffected during the construction or as the construction progresses. Okay. So, by the way, if you have some questions, you can interrupt me while I'm discussing. Okay. Then the accuracy will depend on the project, no? Project requirement. So it could be from centimeter to millimeter level. So I think this is this is good enough, a centimeter level of accuracy. No? Then horizontal control establishment is done by traverse, triangulation, trilateration, or any combination of those mentioned methods. But again, that is the classical method, classical way of establishing controls. We have now the revolutionized. We have the use of total station, diba? And the use of GNSS, or the Global Navigation Satellite System, or the Global Positioning System, or GPS, no? So the advantage of this equipment, we could say this is a high technology. This is high-tech na lang. I'm out of words. Anyway, high-tech or high-end equipment, which is it improves the acquisition and layout time. Meaning to say, if we use this kind of instrument, it is faster, no? So I will not go deep, or I will not go deeper with totalization and GNS technology. If you want to, you can research what's the use of GNSS and the totalization. Okay. So in vertical control establishment is run by leveling method. Again, this is a classical method or classical way of establishing vertical control or elevation. No. So the other is by the use of the global navigation satellite system, no, or GPS. No. So again, there's no strict rules on what equipment or methods that you'll be using in establishing controls, as long as it fits with the accuracy requirement and also the time frame. If you are in a hurry, then I prefer to use the new technology. But if you are on the chill, no, chill, relax, then you can use the conventional way. Okay. So here shown is the example. So this is the design, for example. So you have your design of the building, then you have your controls on the ground. Then from this, we use these controls to establish this one based on the design. So that's how we project it. No. So based on the design, we have these controls on the ground. Then on the actual ground, we use these controls to establish, to relocate the points or to lay out this structure or markings, diba? So as you can see, is distance away with the construction site. Tendency, if you put these controls near to the site, diba, tendency matandog siya, mawala, and so on. Isa pa, ma-damage or may lagtan. So, ano siya. It's very important. Not too far away and not too near. Okay? And from this, once we have the controls, we can establish, for example, we have a vertical control. We use the vertical control to lay out specific depth of a pipe, diba? So, such as this one. Okay? Then we have the batter boards. No, it's a different kind of control because batter boards were used for, we place a string there for that. Makita natin ang layout sa building, di ba? Such as this one, and so on. So this is very common in local areas. Even mga, what we call mga panday, they use batter boards to lay out the building area. Okay. So next is we have the most important, another important survey is the relocation survey. So property boundaries of a project site must be mapped and monumented. So for example, the specific land was acquired for construction purposes. First thing to do is we conduct a relocation survey. Meaning to say, relocation survey, we establish the corners based on the description. So again, this ensures the placement of construction within the limits and we avoid the encroachment on other properties. So what about for example, this is the the construction site based on the data on the actual area, we need to relocate these corners, di ba? We need to reestablish these corners. For that, when we try to design a construction, we try to design a building or structure, we can assure that when we conduct our construction on the actual area, we can assure that our structure is within the limits of the property, di ba? So, no? So, relocation survey is important, and this is useful in the design process stage, ensuring the design is within the perimeter of the property. So, before anything na construction activity na pagabuhaton is the boundary should be set well or should be laid out on the ground na established. For that, if we already identify the corners on the actual area, then we can enclose that area, then we can proceed to construction proper. So an example here, I'll be showing an image of this we can call this a construction now. No, supposedly the boundary is this wall. Okay, this wall. However, the owner of this house extend his roof outside on his property premises. Therefore, this structure is encroaching. No, encroach na siya, encroach. Encroach na siya sa line property. So, by law, this is not allowed, di ba? So, tendency ani, if we do not conduct relocation survey, let's say you just merely or arbitrarily select area then construct a building. Tendency, if that building is not on the specified area for construction, tendency you will be having a big problem. Meaning to say, kaya ba nimo ibton ang balay na sementado niya aron sa correct niyang location? Diba dili? No? So what we are trying to emphasize here is we need to conduct relocation survey before putting out structures. No? And this is not acceptable. No? Siyempre, mareklamo ang adjacent lot or owner. Oy, naglapas naman ka. So, na. So, what will happen? This should be removed. No? So, kana, ma-remove na siya. So, what are we trying to avoid if we conduct relocation survey? First is time and money. Time and money, first and second. And also, we avoid problems of, let's say, long arguments, cases, etc. No? So, before we put any structure, especially structures that are somehow permanent, we must ensure the boundaries of the lot where the construction site or the constructions or the structure will be put into. Yeah? So that is the same with this. So, okay, so much for that. So hopefully you get what I mean. Then, here's a sample sketch plan. So after the survey, you need to produce a map. Diba? It could be if you can add on a structure idea or so on and so forth. You have the technical description relating to this parcel, then so on. Okay, so this is more focused on property surveying, of course. Anyways, then as you can see here, uh, this is a corner established on the actual area, no? So for that, the owner is guided where is the limit of the construction site, no? And lastly is once we already next is the topographic survey. So again, a topographic map of the area has to be prepared for feasibility studies and to aid the engineers in developing project designs. So such as this one, we have the topographic map or the contour map, which means we can obviously see here the topography of a certain area. So obviously this area is going uphill, no? This area is somehow plain. So by looking at this map or this output, we can recognize we need to excavate this area. For that, we can level this surface or whatsoever, no? And also for the design, you have this topographical feature. You would able to design road, di ba? So such as that one, no? Okay. Then just to clarify, by the way, topographic survey, there are so many methods that we can employ, such as I'll just mention the current method. We can use total station for that point. Then we will get the horizontal and vertical coordinates, or using global navigation satellite system. But again, I will not emphasize more about it. No? So it's up for the student to research about that. Okay. So just to clarify some terms, no, we have three different kinds of three-dimensional data files. So in general, we have DEM or digital elevation model. So this is the common term as what you have seen here. No, these are DEM. But to be more specific, we have DSM. This DSM is a digital surface model, which is a three-dimensional representation of the Earth's surface, which includes all object features above it. So when we say surface, what we are seeing on the surface, we also indicate it on the data or here on the map. For this one, it's not a DSM. Wala tayo DSM, there is a sample picture. DTM, we have DTM, which is a digital terrain model, which is a 3D representation of bare Earth. We need to say bare Earth, no artificial objects, no like trees. Meaning to say this one, this one, manisha. This is DTN, digital terrain model, or common term for this one is the contour map. Okay. And lastly, we have the TIN or triangular irregular network. This one is a vector-based surface or sea bottom made of irregularly distributed nodes and lines with the three-dimensional coordinates of points that are arranged in a network of non-overlapping triangles. So somehow it represents surface. Actually, this TIN is this one. no, ako siya gi-convert, no? So this is another way of visualizing the surface, the area, no? Okay. Then another method we have, there are so many methods today, current and up-to-date methods. So one of these, if you have a drone, or it could be fixed wing or quadcopter, so we can produce something output like this. Okay. Okay. So that's for lesson 1.3. Do you have any questions? Hello, do you have any questions? I cannot hear you clearly. Let me see. Balmorda. Do we have no more questions or clarifications of topic? How about the others? Okay, so I think we're done. So if wala na tayo questions, so I'll just